So continuing on with the 2.3 using principles together, take a look at a couple of these. Now, notice this first one. A lot of fractions going on. And can you move things around and manipulate it and get the right answer? Yeah, you can. You could subtract 2/3 from both sides and then multiply by the reciprocal of 1/4. That's one way to do it. But I want to show you that clearing the fractions again. So if we look at this with denominators 3 and 4, the lowest common denominator here would be 12. So if we multiply each term by 12, notice what happens. So if we have 12 over 1 times 2/3 plus 12 over 1 times 1/4 t equals 1/3 times 12 over 1. Okay, so what we can notice is the cancellation that occurs. Now, the denominator here, 3, cancels with that, leaving us with a 4. The denominator of 4 here cancels, oh boy, the denominator of 4 here cancels with the 12, leaving me a 3, and this denominator of 3 cancels, goes in that 4, leaving me a 4. So notice, we've got rid of the denominator here. We have a 1 here, we have a 1 here, and we have a 1 where that would be. Now if we just multiply straight across, you'll see we have something. So 4 times 2 is 8, so we'll have 8 plus, because we respect the addition sign there. The 4 cancel with the 12 there, give me a 3, so 3 times 1 is 3, and we have the t, so 3t equals, here 4 times 1 is 4, equals 4. So we've reduced this problem that had a bunch of fractions that could have got messy into something that doesn't have fractions and isn't messy, by multiplying through by the lowest common denominator. So the procedure is called clearing the fractions. Okay, so now for solving this, subtract 8, because we want to get all the number terms on one side. 8 minus 8 is 0, so we get 3t equals 4 minus 8 is negative 4. And then the last thing we have to do to get our t all alone is divide by 3, and we get t equals negative 4/3. And that is the answer we're looking for there. So I'll illustrate this procedure again on this next problem. This 5/3 plus 2/3 x equals 25/12 plus, this should not be that. That should be a 5 over 4x. You couldn't solve it elsewise. Plus our 3 over 4. So just noting this, if we have denominators 3, 3, 12, 4, and 4, the lowest common denominator there is 12. So I'm going to multiply each of these terms by 12, which is a 12 over 1. So 12 over 1 times 5/3 plus 12 over 1 times 2/3 x equals 12 over 1 times 25/12 plus 12 over 1 times 5/4 x, and then I guess I'll have to do this last one up here. I'm running out of space. 12 over 1 times 3/4. Okay. Now, once again, we're doing this to get rid of all the denominators and get rid of the fractions. So here, 3 cancels with the 3 and the 12, leaving me a 4. 3 cancels with the 3 and the 12, leaving me a 4 again. Here, this 12 cancels with the 12, leaving me a 1. The 4 goes into the 12, leaving me a 3. And this 4 goes into this 12, leaving me a 3. So all the denominators are now 1. So we can just multiply straight across. So we have 4 times 5, that's 20, plus this 3 went into the 12 4 times. So 4 times 2x is 8x equals, the 12 cancels the 12, so 1 times 25 is in fact 25, plus 4 goes into that 12, 3 times 5x is 15x, and then finally 3 times 3 is 9. So now this is the problem we're left with, no fractions. I want to simplify on each of the individual sides. So on the left side there's no like terms, so we have 20 plus 8x. On the right side, our 25 and our 9, that's 34 plus 15x. So now we need to get all the x's on one side, the numbers on the other. I'm going to move the x's to the right, so subtract 8x, subtract 8x. And if I'm moving all the x's to the right, I want to get the numbers to the left. So here, if I subtract 34, we can do this step all kind of together. So I'm moving the x's to the left, or excuse me, the right, and we notice that 8x minus 8x is 0. So that's what we have here. 15x minus 8x is 7x. So I move the x's to the right to keep my x's positive. Move the numbers to the left. 34 minus 34 is nothing, so we just have our 7x on that side. 20 minus 34 is negative 14. Then we have negative 14 equals 7. Divide by 7 on both sides. And move over here. We get negative 2 equals x. And that right there is the answer that we're looking for. So clearing the fractions, a little bit tricky, but definitely worth the time to learn it. It's going to actually help a lot in the future with some different problems. So this next one, we have decimals. No big deal. We have both variable terms and numbers on both sides, so I'm just going to get all the variables on the left side. So if I have negative 8.4x, adding 8.4x, adding 8.4x, we can do that. So 2.1 plus 8.4 is 10.5x. We have plus 45.2 equals. On the left side, or on the right side, we've canceled our 8.4 x's. We just have 3.2. So the x's are on the left. We want to get the numbers to the right, so we have to subtract off our 45.2. So we have our 10.5x that carries down. These cancel out, so this equals. Now, this one you can do with your calculator. I'm just going to do that. So 3.2 minus 45.2. And that's going to give us negative 42. And then finally we're dividing off by our 10.5. And 42 divided by 10.5 is going to give us 4. Because we have a negative divided by a positive, we get x equals negative 4. And that's the answer there. So let's take a look at the next one here. We have some grouping symbols, so we want to get rid of these parentheses before we do anything else. So we're going to use that property of distribution, that is, this 8 we're going to have to multiply by the 3x, giving us 24x. We're going to have to multiply the 8 by the 2, giving us 16. And that equals 30. So we've gotten rid of the grouping symbols using distribution. We would have simplified the inside, but 3x and 2 are not like terms, so we can't do that. So now we have variables and numbers on the left and just numbers on the right, so it makes sense to get all the numbers to the right side. Subtract 16. So we get our cancellation, so we get 24x equals. Now 30 minus 16 is going to give us 14. So the last thing we do is divide by 24, and we get x equals. Now, we want to simplify this 14 24ths as much as possible. Both of them are even, so if I divide both of them by 2, or cancel the 2 that's common to both those, we get 7/12, and that is the simplified answer that we're looking for there. Okay, so now moving on to these next two. Now, these next two are going to illustrate a couple different things, and let's just let the math take us to where we're going to go. Now, we have numbers and variables on both sides. So let's get the variables on one of the sides. I'm going to get them on the left side. So in order to get rid of this x right there, I'm going to have to subtract x from both sides. Now if I subtract x from the left, x minus x is 0. So you get negative 23 equals, here x minus x is 0, so you get negative 23. Now the question, does negative 23 equal negative 23? It does, yes, which means that you can put any number in you want for x, and it's going to be true. Like, negative 23 plus 1 is the same thing as 1 minus 23. Negative 23 plus 2 is the same thing as 2 minus 23. So you can put anything in there, so I'm going to put all real numbers. And that is the solution. That is, you can put anything in for x that you want, and it's going to be true, because the variables went away and we got down to something that is clearly true. Now let's take a look at this one over here. Now I'm going to move the variables to the right this time, so in order to get rid of that negative t, we're going to add t, add t. Now if we add t to both of these, negative t plus t is 0, so we get 17. Here if we add t, negative t plus t is 0, so we have 68. Now does 17 equal 68? No. What that means is there is nothing that you could ever put into t to make this statement true, because the variables went away and we got something that's clearly not true. So this is no solution. Or sometimes it's denoted by this, which is the empty set, meaning that there is no number that fits in there and works. Now notice, both the last two examples, we got rid of the variables. Here we got rid of the variables, but we got something that's true, so it's all real numbers. Here we got rid of the variables, and we got something that's false, so there's no solution. So two distinctions right there that you want to take a look at. Now these last two, we're just going to finish up with these and do this. We want to get rid of all the grouping symbols. Now this first one, our 5r is going to carry down. Now this negative that's in front of the parentheses is really like a negative 1. So in our distribution, negative 1 times 2r is negative 2r. Negative 1 times 8 is negative 8 equals 16. So we distributed the negative to everything inside these parentheses. Now it's time to combine like terms. 5r minus 2r is 3r minus 8 equals 16. We have variable terms and numbers on the left, but just numbers on the right. So let's get the numbers to the right. To get rid of the 8, we add 8 to both sides. Cancellation there. So we get 3r equals 16 and 8 is 24. Then finally dividing by 3, we get r equals 8. So that's the solution we're looking for there. Okay. This next one, same thing. A lot of distribution going on. So we want to make sure that we get rid of these grouping symbols before we do anything else. Now, our 11 is going to carry down, but this negative 4 has to multiply by the x, giving us negative 4x. Negative 4 has to multiply by the 1, giving us negative 4. And our negative 3 carries down. Okay. Over here, we have our 11. Now we distribute our 2 in. 2 times 4 is 8. 2 times our negative 2x is negative 4x. And then finally we have minus 16. So we've got rid of these grouping symbols using distribution. Now we're going to combine like terms on an individual side. We have 11 minus 4 minus 3. So 11 minus 4 is going to be 7 minus 3 is going to be negative 4. So we have, positive 4. So we have 4 minus 4x equals. Over here, if we have 11 plus 8, that's going to give us 19. 19 minus 16 is 3, so we have 3 minus 4x. So, now we want to get all the variables on one side. I'm going to get the variables to the left, so we add 4x, add 4x. Negative 4x plus 4x is 0, so it cancels, so 4 equals, here negative 4 plus 4 is 0, so we get 3. Now, this is just like these ones up here, where we've got rid of the variables. So there's only two choices. It's either all real numbers or no solutions. Because 4 does not equal 3, no solution. And that is what we're looking for there. Now if it was 4 equals 4, it would be all real numbers, and that's the distinction between those. So hope that worked out and you learned something there.